Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Let's have another example on superposition. For the beam loaded as shown below, determine all support reactions. Ci is constant. So this is a combination of rectangular load over the entire span and triangular load. For the triangular load, it is 35 minus 20, so 15 kilonewtons per meter. For the uniform rectangular load, it is 20 kilonewtons per meter. So if we imagine support B is removed, then the deflection at B is expected to be W1 L to the fourth over 30 EI for the triangular load and W2 L to the fourth over 8 EI for the rectangular load. So let's divide the loading into that manner. So call that R sub B, A sub Y, and the moment here, let's assume positive or clockwise moment as shown at the left. Call that MA. So delta B downward is W1 L to the fourth over 30 EI for the triangular load plus W2 L to the fourth over 8 EI for the rectangular loading. W1 is 15 kilonewtons per meter, 35 minus 20. W2 is 20 kilonewtons per meter, and L is 6. So delta B downward is 15, 6 to the fourth over 30 EI plus 20, 6 to the fourth over 8 EI. Combining, delta B downward is 3888 over EI. Then we apply the upward reaction at B. It is treated as a concentrated load at the end of the cantilever beam. The upward deflection is PL cube over 3EI. I hope you can recall it. Then P is just RB. So R sub B times 6 cube over 3EI. Upward deflection at B. So upward deflection at B therefore is equal to 72 R sub B over EI. So equating, then they just use absolute value because they should be equal because there's no movement at support B. So 388, 72 RB over EI equals 3888 over EI. Cancel out EI. RB is 3888 over 72. And that is equal to 54 kilonewtons upward. Of course, AX is 0, not shown, but obviously it is 0. So AX is 0. Then let's compute for MA by summing up moments about A0, clockwise positive, because this is positive moment direction for MA clockwise, then counterclockwise at the right. So MA plus moment due to the uniform loading 20 times 6 times 3. So we take note, we sum up moment about A plus 1/2 of 6 times 35 times 2. 1/3 of 6 is 2, the moment arm. So 1/2 of 6 times 15 kilonewtons per meter times 2. Then minus RB, which is 54 times 6 equals 0. So solving for MA is negative 126 kilonewton meter. So it should be counterclockwise. So let's just make the answer that's final because we assume it is positive. Finally, for AY, we sum up moment about B equals 0 so that we can check equilibrium summation versus Y, and I want you to do that. So AY times 6 plus MA, which is negative 126 minus 20 times 6 times 3 minus 1/2 of 6 times 15 times 4. 2/3 of 6 is 4. Moment arm equals 0. So AY equals 111 kilonewtons upward. So that's it for this problem.